of this device, DIY wallet. You can see the website here. That's the company.
Specter.
Yeah. Specter Solutions.
Swan now.
Yeah.
Like Steph.
So how are they different than Sparrow?
Sparrow is a software wallet, and this is a hardware wallet. It's different.
So now
But they have also the same team, Stepan and Moritz. They developed a software wallet, and actually for multi-sig you need a coordinator. You can also do it in Bitcoin Core, but it's less user-friendly because you need to.
But you can use Sparrow too.
Sparrow, Specter, Desktop, Blue Wallet is good also. So yeah. And actually the demo I will use Sparrow for the testnet transaction. And in NixOS it's very easy because you can install it in one command.
Yeah, Nix on that one.
Yeah. Don't forget to check the PGP signature and everything. Can we start? Okay, so welcome to the workshop, hands-on workshop. Before we start, a couple of words about the company, Hodling SA. It's based in Neuchâtel, Switzerland. It's a very small company. We are actually only 2 people. And we provide expertise and services related to Bitcoin self-custody, multi-sig wallets mainly. The last slide just summarizes where we are based and the website. So we can start the demo, which is here.
Do we need internet?
Yes, because you need to clone the Git repo.
So can we, do you know the Fanta drones? The Fanta drones Wi-Fi is working. Fanta drones Wi-Fi.
Maybe you can even use my phone, or if you can share your connection.
Yeah, I shared my connection. It's called
So
AX, and the password is internet1. Can you maybe write Pix?
Where? Here?
Yeah, just internet.
Pix.
Yeah.
Okay, so before we start the demo, I would like to say that the wallet and so the hardware wallet and the software behind it, called Specter Desktop, is developed by this team here, Specter Solutions, so Stepan and Moritz. So all credit goes to them. And now we can start the demo. I will be doing a demonstration on NixOS because it's easier, but you can use obviously Macintosh and Debian Ubuntu devices. So the first step is obviously you need to clone the repo. I have already done that, so do you have problems with that, or is it fine? Those who are trying to do it now?
No, it takes a bit. The recursive.
Okay, so then I can skip also the commands because you need to wait for.
Like I'm not sure I know how to do it.
Go to that.
You don't know?
Back to the other.
Can you help him, please?
Yeah.
You have, by the way, all the instructions. You can find them on the GitHub page in the build.md file. Okay, so now we are ready for the simulation. Make simulate, and this is exactly how the device looks inside. It's the same software as the wallet. So the first time you start it, I already initialized the device to speed up the process, but the first time you start it, you need to choose a pin. And this pin is important because it will, those are anti-phishing words, and you will, the first time that you flash the device, there will be an internal secret generated, which will be combined with the pin that you choose. And so if someone tampers with your device, you will know right away because the words will not be the same on the next boot of the device. So this is very important, and many popular wallets ignore this feature, which is important for security. So I already initialized the device, and I chose simply 1, 2, 3, 4 as the code. And you can see the words rand, gap, special, piece, burst, and I have written them down here. You see my words, rand, gap, special, piece, burst. So if, for example, I take now the physical device, the hardware wallet, and I simply do an upgrade of the firmware, the words will not change, because the internal secret of the device was not changed. But if I erase completely the device and I flash the initial firmware once again, the words will change, and I will know that something happened with the device. So you can click on next, and this is the main menu of the device. The next step would be to generate a key. I have already generated a key, but let's go once again all together through the setup. You click on generate key, and you have two options. You can have 12 or 24 words. Let's choose 24. And now here, one interesting feature of this wallet is that you can edit, you can add your own entropy. So the device has multiple sources of entropy. There is the true random number generator. You can add, you can change the words. For example, I chose the word mouse, and I can change the bits here, and it will generate a new word. And if I'm not mistaken, I'm not sure if Stefan implemented the microphone use. I don't think so, but the touch screen, yeah, the touch screen also is one of the sources of randomness. So now, for example, let's choose the word mouse, number 6. And if we go back here, this is the official list of. Can you see? It's very small. Let's try to find the word mouse. Mouse, yeah, it's here. You see? Here. So if we go back here on the word mouse, you can see that it corresponds in binary to the binary version of the word in the official BIP39 dictionary. And for example, if we go back here, mouse, um, mouse, and for example we change just this one, so it was one here and then we move it here, for example. We just add one bit. It should become the word move, and this is how you can actually check on your own that the entropies, the implementation of the additional entropy is correct. So let's just do that. So we will move this one from this position to the next one, and it should become move. And so like this, and you see now it's the word move. And maybe, I don't know if you have noticed, the 24th word changed as well. This is the checksum word, and it is supposed to change because it takes into account all 23 previous words. And this is also one of the ways that you can use, for example, to verify that your backup is correct also, if you have air-gapped devices, because if you have made a single mistake somewhere, the checksum will not correspond to the original backup, so you can check like that. So now the next step, because this is a demonstration on testnet, we need to go to settings and choose testnet. We can go back, and so now we can create we already have a single SIG wallet. You just click on wallets, the default one, and this is your wallet. Single SIG, you can change addresses here, generate many of them, and so on. If we go back to the first one, now I can send some testnet. Sorry? Yeah, this one. TB, it's for testnet. So I can send some coins to this address now, for example. Where is it? It's here. Copy. I need to use this here. So this is the address. So just 1 second. And here. So this is the transaction ID of the testnet transaction that I just made with on this machine. I have Electrum wallet, and I'm using testnet coins from this one to send it to the device, to the Specter DIY.
Can you set it to Signet? Easy?
Yes. Yeah. Look here. If you go back, settings, network, and you have Signet as well. Testnet. So let's check. It should have been mined by now. See. So yeah, it was mined, and now we are ready to spend the funds from the simulator, from the Specter DIY. And to do that, we will use, for example, Sparrow. This is one of the options. Obviously, you can use Electrum, Sparrow, Specter Desktop, which is developed by the same team as the device. Sorry? Yeah. You can choose any wallet that supports PSBT. So. If we go back here, transactions, it's offline. Transactions, finish loading. So I just need to take the address, the destination address, which is this one. Now we go to Sparrow and we click on send, pay to 511 test amount. Okay, let's send everything. Create transaction. Finalize transaction for signing. It will generate a PSBT that we have to save. We can save it directly because this is a simulator. So if you're using the physical device, you can communicate, for example, with QR codes. If you have the complete device that has a QR reader, or you can use the SD card. But here I will directly save the PSBT into the memory of the simulator, which is here. Then FS, yeah, then SD, and yeah, test 3 PSBT. Okay. Now I can go back to the device, to the simulator, here, and we go back, open SD card file, and you can see test 3 PSBT that I just added. You click on it. Source wallet for some input is unknown. This is weird.
This happens to me, I just re-import the export into Sparrow, for example.
But the Sparrow already has the XPub, so it's weird. Anyways, this message simply means that it does not recognize as you said, the XPub, but it was not supposed to happen. I did a test transaction before, so it's not a good practice to ignore verification. So, but for the purpose of this demo, let's just click on confirm, and here you can have detailed informations, the amount that you are sending and the address that you are sending to. You can You click on confirm.
Yes. I think it didn't generate the wallet on the.
Ah, oh, I
on the
forgot. I
device.
forgot to load. I forgot to load actually the wallet here.
Yeah.
Wallets and wait. I forgot to load the wallet on the. Yeah. It was there, yeah. I cannot scroll.
Yeah, to scroll you need to click, no, not here, but yeah, it's a bit weird with the
But
simulator.
it's
Huh?
the key disappeared. It was here before. It's weird.
Scrolling.
Ah, I know, because I just realized that I regenerated a new key for the. This is why.
Yeah,
I was using a completely different key before, so sorry. So then I have to save. Yeah, I need to save the key that we generated all together. Sorry. I need to save the key here. Let's say internal flash. You call it pause. Then I have to go back and export the single sig key, which is here. Yes. I have to go here, add new wallet, test workshop. It is single sig, testnet. Let's say like this. This is the derivation path that we need to enter here. The fingerprint goes here, and the extended public key for testnet here. Native segue.
Yes.
Sorry?
Let him at the front of the derivation path here.
No, it's okay like this also.
Works also?
Yeah.
Oh, okay.
And it's accepted. Now you can apply. 1, 2, 3, 4. Okay, so now we have a wallet that is empty. So we need to send some funds to this one. Receive, copy. Here. So this one. Transaction ID, which is here. Yeah, it was mine. So now we have some funds on the simulator, and we can spend because the XPub is already in the Sparrow wallet. So we can go here. Yeah, you can see that some funds are available. You can click on send. We want to send to this address here. Yeah. Test. Max. Okay, let's send everything. Create transaction. Finalize. It will generate a PSBT as before, but now it should work because the device has the correct XPub. Save transaction. Let's save it directly onto the simulator. FS, SD, test, let's say, new. Save. If I go back to the device, I should see it here. Yeah, it's here. And now we don't have any errors because obviously it has the correct key. You can see the details as before. You can confirm, and you see that the device has generated a PSBT which now has the signature derived from the key that was made by the simulator. Confirm. Crypto PSBT. If you have a QR reader, you can use that. I will save. Wait, where does it go? Open SD card. It's here, so now I can go back here and just click on load transaction. Find the correct PSBT. FS SD, which is this one. Open it, and the transaction is ready to be broadcast. Yeah. So that's it. How much time do we have? Do we have time for the multi-sig? 3 minutes. So okay. We have time. So this was single sig, and let me just, it will be very, very quick. I just wanted to show you the power of this device, which can import the configuration of the multisig, and actually it will display all the cosigners and tell you which among those XPubs participating in the multisig is your device. And many popular wallets, very well known, do not support this feature. So if we go back to the simulator, which is here, it will not work because I'm not using the same keys. Because I changed the key. But anyways, where is it? I cannot scroll. It's down there. Yeah, sorry, I cannot. Ah, yeah. It's okay. Let's. FS, SD. Let's remove. I don't know which one. Multisig, yeah, multisig is here. So okay. Let's. I don't know. This one. Okay. C2. F48. And test 2 PSBT and test 3 new PSBT. Can we see now?
You need to go back and
Yeah, now we can see. So if you click on, this is the descriptor of a multisig that we created previously. It has 3 keys. One of the keys was from the previous device, from the previous simulator. So I will not be able to show you what I wanted here, but I can explain you. So this is one of the messages that is important, because now the device says that it does not recognize any of the XPubs that are written in this descriptor. So, sorry. And yeah, if I had the correct key, it would be written here that the third key is the XPub that was derived from the seed of the device. So you can see, and in a multisig, if you want to do it the correct way, you are supposed to check on multiple devices that you are using the right XPubs. Yeah, that's it. Thank you.